Well, I'm sure it'll come as no surprise to you that matter is made from tiny building blocks called atoms. The word atom itself means indivisible, meaning that the material cannot be broken down into anything simpler. And chemists today use the nuclear model to describe atomic structure. There are also other models that detail how matter may be put together. For example, you may have heard of the string theory. But most chemistry observations do follow the nuclear model, and it's very easy to understand. So, what is it all about? Well, the nuclear model goes as follows. There are three types of particles that make up an atom. We call these particles subatomic particles. Two of these particles can be found in the nucleus of an atom, the central point of an atom. These are called protons and neutrons. All the mass of an atom essentially comes from the nucleus, in other words, the balance of neutrons and protons. Surrounding the nucleus are things called shells, sometimes referred to as energy levels. And orbiting the nucleus within these shells are particles called electrons. Now, in terms of chemistry, I think it's fair to say electrons are the most interesting particles, as you'll see later. So it's absolutely essential as chemists that we get the basics right. In other words, understanding the properties of each subatomic particle, protons, electrons, and neutrons. If you forget, just remember the word pen. So first let's look at the relative mass of each particle. Protons have a relative mass of 1, as do neutrons. What this means, relative mass, is that the mass of a proton is equal to the mass of a neutron. Relatively, they are the same. However, relatively, electrons have a much lower mass. In fact, you can see that's 1,836 times lighter than protons and neutrons. In some exams, this may be rounded up to 2,000 times lighter. The point is, the mass of an atom comes from the nucleus, from the protons and neutrons, not from the electrons. So if you wanted to work out the mass of this atom, you just count up the individual particles in the nucleus, 7 in total, 3 protons, 4 neutrons. Next is the idea of charge. Protons have a +1 charge, electrons have an equal and opposite charge of -1, and neutrons have no charge at all. Think of charge a bit like magnetism. Two positives will repel each other, but positives and negatives will attract each other. That's really all you have to take from this idea of charge. Similarly, two electrons will also repel each other because they both carry a negative charge. So alikes repel, opposites attract. And also, please remember that protons are found in the nucleus, neutrons are found in the nucleus, but electrons are found orbiting the nucleus in the shells. In an exam, you may get a table like this with certain parts missing, and you'll have to remember these details to fill them in, but it's easy marks. I mean, most of the numbers you have to memorize are 1 or 0, and you just need to remember plus or minus. So here are the key facts you should take from this. 1. An atom's mass is the mass of the nucleus. You just add the protons and the number of neutrons. So as I said, 3 protons plus 4 neutrons equals 7. So this atom has a mass of 7. Secondly, the nucleus has a positive charge, and that's because it contains protons which have a positive charge. The other particles are neutrons which have no charge, so the overall charge is positive. This nucleus in particular has a positive charge of 3 because it has 3 positively charged protons. Also very important, the overall charge of an atom is neutral, and that's because the number of protons with a positive charge equal the number of electrons with a negative charge. So you can see 3 protons in the nucleus and 3 electrons whizzing around the outside which have a negative charge. So even though electrons are much smaller in terms of mass, they still carry the same amount of charge, but in the opposite way, so negative as opposed to positive. So an atom that hasn't been tampered with will have a neutral overall charge. But if you do start playing around with it by adding or removing electrons, you will give that atom a charge. You could add more electrons, giving it a negative charge, and you could take away electrons, giving it a positive charge. Either way, you create an ion. An ion is a chemist's word for a charged atom.